All right, welcome to the primer video for setting up a graph for Chapter 9, Section 4, sine and cosine functions. We're going to take this slow. You're going to need to pause. You're going to need to rewind. You need your unit circle, the plate, or the one you drew with you. This is the basic way to set up your graph. It is not perfect. It does not... it will not apply in all situations, but we're learning, and if you're going to do this with technology like graphing calculator or Desmos, you need to at least appreciate what you're looking at, and this will help you start. So I'm going to switch over. I'm going to set up the graph with you. So you need a huge piece of paper. In the middle of the paper, this is as far as I can zoom out, in the middle of the paper, we're going to draw a giant y-axis. Halfway through, we're going to draw a really large x-axis. I don't know how much space I really need yet, so I'm going to go the entire length of the page. All right, so I want you to look at just quadrants 1 and 4, and I hope that this is zoomed in. Okay, so you're going to have to count with me. We are going to count by pi over 6, but that doesn't mean that we're skipping the over 4s. All right, and you'll see what I mean in a second. So here we have 1 pi over 6, 2 pi over 6, which is pi over 3, 3 pi over 6, which is pi over 2, 2 pi over 3, 5 pi over 6, and pi. Okay, let me see if I can zoom in better. Not that my handwriting's great, but we can see that we have, this is quadrants 1 and 2 on our unit circle. Remember, we're still just drawing in quadrants 1 and 4 on the XY plane. So 1 pi over 6, 1 pi over 3, 1 pi over 2, 2 pi over 3, 5 pi 6, pi, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. But of course we simplify. Now, that doesn't mean we're skipping pi over 4. Where do the over 4s go? Well, 1 pi over 4 is halfway between pi over 6 and pi over 3. 2 pi over 4 is the same as pi over 2. So 3 pi over 4 is going to go right here. I'm going to write it down here in purple. All right, so these are halfway between pi over 6 and pi over 3, halfway between 2 pi over 3, 5 pi over 6, just like in our unit circle. All right, let's keep going. This was 6 pi over 6, so this is 7 pi over 6. Next up is 8 pi over 6, which simplifies to 4 pi over 3, and then 9 pi over 6, which simplifies to 3 pi over 2. 10 pi over 6 simplifies to 5 pi over 3. 11 pi over 6 simplifies to nothing, 11 pi over 6. And finally, 12 pi over 6 is the same as 2 pi. Okay, I didn't need the whole unit, the whole graph paper. Let's go backwards though. We got 1 pi over 4, 2 pi over 4 is the same as pi over 2, 3 pi over 4 went here, 4 pi over 4 is the same as pi. So we have 5 pi over 4 in between 7 pi over 6 and 4 pi over 3. 5 pi over 4, 6 pi over 4 is the same as 3 pi over 2, and 7 pi over 4 goes right here. Okay, and then finally 2 pi. All right, we're only going to go up to 2 pi over here. Sometimes you're going to need to go up to 4 pi. Sometimes you're going to need to go up to 3 pi. Sometimes you're going to go up to 6 pi. It really just depends on the problem that you're given. We're going to get into that later. Right now, can we translate the entire unit circle, just one rotation, one revolution, from 0 to 2 pi onto the graph? Now, hopefully by now you've paused, you've rewound, you've replayed. We're going to go backwards. Okay, again, this is just the standard graph to get an appreciation for your sine, cosine, and eventually tangent, cotangent, secant, cosecant curves or functions. All right, so pi over 6, well, if we go backwards, we got negative pi over 6, negative 1 pi over 3, negative 1 pi over 2, negative 2 pi over 3, negative 5 pi over 6, negative 1 pi. And remember, it's negative 1 pi over 6, negative 2 pi over 6, negative 3 pi over 6, negative 4 pi over 6, negative 5 pi over 6, and negative 6 pi over 6 that we, of course, simplified. Then we have negative 7 pi over 6, negative 8 pi over 6, which is negative 4 pi over 3, negative 3 pi over 2, negative 5 pi over 3, negative 11 pi over 6, and negative 2 pi. Okay, now it should be a mirror of quadrants 1 and 4 over in quadrants 2, 3 on the negative side of the x-axis. But we got a negative pi over 4. I'm not going to write it in. It's the same as over here. Halfway between negative pi over 6 and negative pi over 3 is negative pi over 4. Then here's negative pi over 2. We already wrote. So halfway between negative 5 pi over 6 and negative 2 pi over 3 would be negative 3 pi over 4. And here's negative 4 pi over 4, which means this should be negative 5 pi over 4, halfway between negative 7 pi over 6 and negative 4 pi over 3. Also halfway between negative pi, negative 3 pi over 2. Okay, so 4 pi over 4, negative 5 pi over 4, negative 6 pi over 4, and negative 7 pi over 4 right there halfway in the box. And we're going up to negative 2 pi. So if you are ever wondering what your x-axis should be for a sine, cosine, tan, cosecant, secant, cotan functions, you should just go with the basics. Negative 2 pi over 2 pi. It's tedious. The more practice you get, faster it goes. Now, we need our y-axis, though, and the basic y-axis, if you know, like, let's look at our unit circle. What is the largest number in our x or y values? Well, it's actually just it's 1. So then I'm going to do 2 boxes, and that's going to get me a quarter. I'm going to do 2 boxes, that's going to get me a half. 2 boxes is going to get me 3/4, and 2 more boxes get me 1. So the largest number is 1, and then I split it up. We know that well, actually 1/2 isn't there, but there's numbers, we're going to get to it, to graphing. Oh, 1/2 is there, I don't know what I'm talking about. But we're going to get to graphing later in another video. However, you want to space out your y-axis normally, unless, of course, there is some sort of transformation that makes you want to maybe shrink it or you need more space. But to get a good idea of how the sine and the cosine and the other functions go, it's good to give yourself some space to get up to 1. So we're going to also have to give ourselves some space to get all the way down to the lowest value in our x or y spot, which is negative 1. Okay, here is the basic graph for sine and cosine. We're going to do it again, but we're going to also graph on it in a future video.